Welcome back to my lecture series. In the last lecture, I have completed the basic transformations like translation, rotation and scaling. And also I have introduced that homogeneous coordinate system, and using homogeneous coordinate system it was possible for us to represent all operations in terms of matrix multiplication. The advantage of this matrix representation are of twofold. One is we can easily write computer programs for implementing those operations, because those operators are nothing but the two-dimensional matrix operator, which are very easy to implement using any programming language. And another advantage is that if we can perform inverse transformations. Inverse transformation means the transformations which will just bring back the object to its initial position. So, operations and inverse operations all are represented in the form of matrices. So, they can be multiplied in a chain. So, that is called concatenation of operations, and that is also very much easier if we go for matrix representation of all these operators. We will shortly we will discuss those things in detail. So, before going to that topic, let us introduce two more transformation operations. These are mirror reflection and shear. Now, what is mirror reflection? So, in that case we will assume that a mirror is represented and the object is reflected with respect to that mirror. For simplicity, let us consider that the mirror is initially aligned along the principal axes. Let it initially the x axis. So, we are considering again that two-dimensional Cartesian coordinate system. This is origin x axis, y axis, this is negative x axis, and let the mirror is aligned along x axis. Let us consider any object point P whose coordinate is x y, and P is reflected with respect to this mirror. So, from our basic concept, earlier concept of physics, elementary concept of physics, if we reflect this with respect to this x axis, that P is reflected at P dash, the coordinate for P dash is very obvious, x remains same, this remains x, and y is just opposite, that is minus y. So, we can write the transformation equations as x dash, this is our x dash. So, x dash is equal to x, that remains unchanged, and y dash is equal to minus y. So, these are transformation equation. Now, once we have that transformation equations, we can easily represent those transformation operations, transformation equations in the form of matrix. Now, let us do that. So, x dash y dash 1, that is P dash, it is obtained in the matrix form. This is nothing but x minus y 1. Now, we have to introduce the operator for this operation, so that if this operator is operated on the original point x y, then these will be obtained. So, what will be that operator? So, we can write that, we can write this as some operator operated on object point x y 1. So, what will be this operator? So, that we will get these equations. These are this definitely as x remains same. So, this is 1, there is no y component. So, y is 0, and there is no constant term. So, that is also 0. So, this is 0 minus 1 into y, that is minus y, 0 and 0 0 1. So, this is your x dash y dash 1. So, in matrix equation form, this is P dash, this is the operator. Well, let us call this operator as mirror reflection operator M with respect to x axis mx, and that is operated on the object point P, where mx is given by this. This is your mx. In the same way, if we consider that y axis is the alignment for the mirror, if we consider that, and if the same point P is reflected with respect to that mirror, then let P is reflected at P1, say. And from our elementary concept of physics, we can easily say that the coordinate for P1 is, okay, in this case, this y remains same, but x is just opposite to earlier one. So, this is minus x and this is y. So, in this case, the transformation equations are x dashed. Here let us call this as x1 and y1. x1 and y1. x1 is minus x, y1 is y. So, these are transformation equations. Again, we can write in the matrix form as x1, y1, 1. This is the coordinate for P1. Some matrix operator operated on the initial point, object point x, y, 1. So, what will be this operator? So that if this operator is operated on this object point, then these transformation equations will be obtained. So, definitely this will be minus 1, because minus 1 into x, this will be obtained. There is no y component, no constant. Similarly, this will be y, there is no x component, so x is 0, this is 1, this is 0 and 0, 0, 1. So, this is our P1 in this example. This is mirror reflection operator with respect to y axis, and that is operated on P, where this reflection operator is obtained by, is given by this matrix. This is our operator. Now, note one important point here, that this mirror reflection operator with respect to y axis or mirror reflection operator with respect to x axis, these are nothing but the scaling operator, where in this case Sx is 1, Sy is minus 1. In this case Sx is minus 1 and Sy is 1. So, basically mirror reflection is also achieved with the help of scaling with scale factor specified this. Here in this case we can also say that P dashed is the scaling operator S with respect to origin, and the scale factors are in this case, okay, 1 and minus 1, and that is operated on P. So, this scaling operator is same as this mirror reflection operator. In this case, this can also be written as P1. This is equal to scaling with respect to origin, and the scale factor is minus 1 and 1 operated on P. So, this scaling operator and this mirror reflection operator are same.